Hi everyone, welcome to the System Design Series, lecture number 8. In this lecture, we will cover one of the most important and interesting topic called as database sharding. And the topics we will cover in this lecture are role of vertical scaling and horizontal scaling in sharding and partitioning, what is database sharding, what is data partitioning, what is celebrity problem in database sharding, and lot more cool things. And let's deep dive into the video. First one, the role of vertical scaling and horizontal scaling in database sharding. In my previous lectures, I have already covered what is vertical scaling and horizontal scaling, but just for a recap, I will tell you somehow what this vertical scaling and horizontal scaling plays a role in sharding and partitioning. First of all, what is vertical scaling? Just a minute. Uh, just a second. First of all, what is vertical scaling? See, vertical scaling means, let us say this is your machine. See, this is your machine. For this is your server. For this server, only you have only one server for your website. Increasing this server CPU, RAM, or capacity is called as vertical scaling. Means improving your server's power without adding more servers. For single server, we are increasing the CPU, we are increasing the hardware power, increasing the RAM, increase the capacity of the server is called as vertical scaling. Initially, let us say your server can handle only 100 users, but after increasing the CPU power, your server can handle uh, 300 users. After somehow increasing your CPU power, like I mean your server power, it can handle around 500 users. But there is a limit for vertical scaling. Up to that limit only we can increase the CPU power or RAM or capacity. We can implement vertical scaling only up to that limit. So it depends upon the type of the server we use. So there is a problem with it. So what is an alternative for vertical scaling is horizontal scaling. So what is horizontal scaling? In horizontal scaling, the thing is, in horizontal scaling, let us say our server capacity is 100 GB. Initially we have a single server, and this server capacity is, sorry, one, okay, 1000 GB. You think of this server capacity is 1000 GB, and we break this server into some parts, and let's say this is 250 GB, then this server is, then this server, and this server, 250 GB. We have divided this server into 4 parts. Now these servers will handle the data, means they will share the load, they will share the read write operations. Let's say they will share the data read write operations. And uh, since I'm discussing about database uh, sharding, I want to discuss about database sharding and partitioning. But why I'm discussing about horizontal scaling and vertical scaling? See, in horizontal scaling, the load is distributed. The load is distributed to the servers. The same thing we have written database sharding. See, database sharding means, in, let us say, means your database server is deployed in some server. See, this is a very big server. In this big server, your database got deployed. Your database got deployed in a very big server. This database server can be any Oracle, MySQL, Postgres SQL, whatever it is. It is deployed on this big server, and this server can be any cloud server also, like Amazon EC2 and Azure and GCP. So what is database sharding? Database sharding means deploying your database on multiple shards. Here, shard in the sense there is a server, and think of you're breaking the server into three parts. I'm taking three parts. You can take any parts, depends upon your trade-offs in the company. And this server, breaking this database server means this database server into parts. This part, each part is called as a shard. Think of, see, this is the database. This database is broken into three parts, and each part is called as a shard. So this is database sharding. Now what is database partitioning? Partitioning in the sense, partitioning means dividing the data. Means, let us say we have 50 GB of data. We are distributing each data in some shard. See, 50 GB of data, right? We were giving 30 GB to this shard, and 10 GB to this shard, and 10 GB of remaining data to this shard. And this is called as partitioning of data. 50 GB data is given to shard 30 GB in 50 GB data. 30 GB data is given to shard A, and remaining 10 GB data given to shard B, and in another remaining 10 GB is given to shard C. This data is partitioning among the servers. And what I have told, sharding means dividing the means dividing the server into three parts. Each one is called as a shard. And data partitioning means partitioning the data. So here there are more cool things like data replication also happens. Means same data can be present in other database server also. Means, if you think this as a server, see, okay, I will tell you. If you think this is the database, we have divided into the database is divided into, let's say, two parts. Same data, same data can be present in same records. That same record can be present in this database also. If this, if for a read operation, let's say if you want to read some data, if load is increased on this database, then this database will perform this read operations. This is called as read replica. Replica means duplicate. This is for this same data. Means this is database A and this is database B, which is deployed on servers. And same data is what the data present in database A is present in database B also. If load on database increases, the load will be distributed to B, since because same data is present in database B also. It will be helpful for database A. So this is called as uh, read replica. Means there is read operations only applying. So if there is no read operations, so this is a scenario we can apply things like, see, that 100 GB. See that, let's say we have divided that database server into two parts. That 100 GB data, the database server into two parts, and we have 100 GB data. We have 50 GB to this and 50 GB to this, and these both data are different. But the very disadvantage and the complex thing here is joining the tables. Means, let us say we want some data. The data is, some part is in this A and some part is in this B. Then combining these two is joining, means doing some database operations upon this. Let's say mm, some part of data in this database and some part of data in this database. So joining these two is a complex operation. That's not that much easy. And also dividing a big database server and and dividing into parts, big database servers and dividing into parts and communicating these servers is also a difficult thing. And one more important thing is how sharding happens, on what basis this database sharding happens. The thing is, there is a key called sharding key. Using that sharding key, the sharding happens in this. See how, let us say, we have users and their names. Think of user ID. There are only two columns, user ID and their names. We have divided our database, think of, we have divided our database servers into four parts. So this is one part. And we have IDs, and we have only IDs, user ID and user name only. So think for a while, how we distribute the data into these four servers, on what basis we distribute the data into four servers. See, let us say, we can distribute with names also, like, from, let us say we have letters from A to Z, right? A to F go to shard 1, and ABCDF, G to some N go to shard 2, and O to some S go to shard 3, some T to Z go to shard 4. So we can distribute this data to these four database server using these alphabets, like, means username starts with A goes to shard 1, username starts with B go to shard 2, up to username F, username it starts with F go to shard 1. So using this, we can, using the starting letter of the usernames, we can shift, I mean, we can distribute the data to the shards. Here username, uh, username is the shard key. Using this shard key, we can distribute the you can distribute this data to the shards. There's another standard thing to distribute the data is called as using IDs. Using this user IDs also, we can distribute the data. See how, we have user IDs, we have divided into four shards, right? So do this modulo operation and distribute the data. See, ID, user ID, this is user ID modulo 4. Why modulo 4 means we have four shards. So we have done modulo operation using 4. If you have three shards, we do user ID modulo 3. Since we have four shards, see, user ID means, let's say user ID is some 5. User ID is 5. So 5 modulo 4 is equal to 1, so it goes to shard 1. So 5 is here, and 6 modulo 4, 6 user ID is 6. This numerator is user ID, 4 is the denominator. User ID is 6, so 6 modulo 4 means 2. So go to, see, this is shard 0. Think of, this is shard 0. I have numbering shard 0 because we can get remainder 0 also, right? So shard 1, shard 2 and shard 3. So 2. See, the possible reminders for 4 is 0, 1, 2, 3 only. For n, the possible reminders are 0 to n minus 1. For shard 5 or shard, sorry, for shard 4, the possible reminders are 0, 1, 2, 3 only.